Solve the following 3 by 3 system, which means 3 equations and 3 unknowns. Our goal to solving 3 by 3s is try to somehow get it to a 2 by 2, which is 2 equations, 2 unknowns. And then we can use a previous section, elimination or substitution, to solve that 2 by 2. So that's what I'm going to do. So I'm going to label these first, label these 3 equations. And after I label them, I'm going to arbitrarily pick 2. I'll pick 1 and 2, and I'll eliminate a variable. You can eliminate any variable you want, but I'm going to go ahead on this problem and eliminate z. I do realize if you eliminate one of the other variables, you get an answer right away, but I'm just going to show you the general case when nothing goes away when you add them together except for what you're trying to eliminate. So if I add these together, I do notice that the z's do get eliminated. So this would, adding the columns just like I did in the previous section, 3x, and this would be a minus 4y. The z's go away, it would equal negative 9. And that will be our 4th equation. This equation does not have a z. It has just x and y. So if I can come up with another equation with just x and y, that will reduce down to the 2 by 2. So I'm going to pick 2 others and eliminate z again. So I'm just going to arbitrarily pick 1 and 3, but you can pick any 2 you want. The important part here, though, is to eliminate z again. I know that if you eliminate x, because maybe x looks kind of easy, then you are not going to get equation, the system to deal with, to have that go down to that 2 by 2. So instead, what I'm going to do is multiply the top equation by negative 3. Why am I choosing negative 3? I'm choosing negative 3 because I want to eliminate z, and I notice that these are, if I multiply the top one by negative 3, then that coefficient of the z would be a plus 3. With the negative 3, it would go away. The z would be eliminated. If I'm going to multiply one side by negative 3, I need to multiply the other side by negative 3, so I do not change the equation. So let's go ahead and do that down here. So that would be a negative 3x, a negative 12y, right, using the Schroeder property, and a plus 3z equals multiplying negative 3 on this side and negative 12. And I'll keep the second one the same. And I notice now when I add up those z's, right, they get eliminated. So I'm going to add up all the columns and I'll get a negative 5x minus 4y. We'll do this column. This will go away, so it just equals negative 1. And I'm going to call that my 5th equation. So I notice I now have a 2 by 2. If I look at equation 4 and equation 5, both of them do not have a z. Rewriting this system, I now think of this as a brand new problem. How would I solve it? You can eliminate x, or you can eliminate y. We can start over because the z's are now gone. Eliminating y looks easy, so let's go ahead and do that. So to eliminate y, I'm going to multiply one of these by negative 1. Maybe the second equation. And if I multiply one side by negative 1, I better multiply the other side by negative 1 so I don't change the equation. And let's rewrite the first equation and not change it. For the second equation, I'm going to go ahead and multiply everything by negative 1 to get a 5x. Negative 1 times negative 4 is a plus 4y. Negative 1 times negative 1 is a 1. And I'm going to add that together, and I'm going to get a 8x, the y's go away, equal negative 8. Divide both sides by negative 8, and we get x equals 1. X equals negative 1. So now I'm going to take one of these intermediate equations without a z, and I'm going to plug in that x equals 1, or negative 1. I'm going to plug that into the 4th equation. So what do I get is 3, negative 1, leave the 4y alone, and the negative 9. That would be negative 3. Rewrite everything. Add 3 to both sides. You get negative 4y equals negative 6, or y equals, divide both sides by 4, negative 6 over negative 4, which is 3 over 2, or 1.5 that reduces to. And finally, we're going to plug both of those answers into one of the originals to get the z. So the first one looks nice and easy, so let's go ahead and do that. And what I get when I do that is a negative 1 for x, 4 times 3 over 2, or 1.5 if you would rather, minus z equals 4. And multiplying fractions, 2 goes in the 4 2 times, so we really get negative 1 plus 6, or 5. So subtracting 5 from both sides, you get a negative 1, negative z equals negative 1, or multiplying or dividing both sides by negative 1, you get z equals 1. So now we have the z, there was the y, there was the x. We have the solution to this system.